Okay everyone, let's talk about vectors now, which is in the curriculum of Physics 12, even though it's math that is used in physics, but because it's part of the physics book and physics curriculum, I'm going to put it in the Physics 12 playlist. So, let's talk about vectors. Something very important, I like to let you know that diagrams are very important in physics. Don't look at them as they are just like, don't underestimate their importance. Diagrams are for communication. Diagrams speak to you. Diagrams are just like formulas. They are very important. You have to make sure you draw them correctly. Okay, now I start with some very important concept in physics. You know that vector is different than a scalar. Scalar quantities have only magnitude, however vectors have magnitude and direction. So vector is something which has magnitude and direction. This is vector A and this is vector B. Okay, now something which I want to tell you it's very important is called Hamsang. In Hamsang. I like you to learn this word. This word means equivalent. So these vectors are equivalent. Now I want to tell you what is equivalent vector of A. I tell you draw equivalent of A or Hamsang of A from here. This is how you would draw it. This is exactly A. And now draw the equivalent of B from here. This is how you would draw it. This is exactly B, is exactly the same thing. These are exactly the same thing. Don't think they are different because they are in two different places. That's not important. Important is they are showing the same direction and have the same magnitude. So as you know, vectors have direction and magnitude. Right? So direction and magnitude is important in vectors. Therefore, whatever that shows the same direction and has the same magnitude is the same vector. So this is called equivalent vectors or Hamsang vectors. They are the same things, exactly the same things. Look at this one. This is vector C. Of course, I tell you draw the Hamsang of C from here or equivalent of C from here. This would be, as long as it's exactly the same direction and the same magnitude, it is exactly the same thing. So, this is very important in physics. Maybe it seems easy, but it's very important, and I will tell you why. Because in many places, this concept is used. For example, when you have a solid and very hard object, maybe somebody tells you, okay, this is the earth, this is the force applied from earth to us, dragging it towards the earth, which is called its weight or mg. This is a force, something is pulling it from here, another force. Another force maybe is pushing it this way. So, and maybe you call this F2. Let's call this F1, F2, and this is mg. So if you want to calculate these, you have to put them all in one point, and that point is the center of gravity. So the center of gravity of a solid object, solid and hard object, would be here, and this is how you should draw your forces. Maybe some people draw it differently for you, but I'm telling you, this is the way you should draw your forces. This is your F now. This is now your mg. You don't need those extra things anymore. And look at the F2. F2 is here. This is F2. So it's good to use different colors, but you have to draw the Hamsangs or the equivalents all from one point, and you will learn why this is very important. So anyways, now you learn the Now maybe there are several other forces involved. For example, maybe there is another force F3 pulling it from here. You draw it from here, because you know that for a hard and solid object, all the forces are applied to the center of gravity. So this is how we can calculate them. Otherwise, they're going to change the shape of the object, and the laws you have learned called Newton laws, everything would be different, and they wouldn't even act the way they, differently. Anyways, now in here, I will tell you, let's give our first lesson on vectors, which is very, very easy one, and you have probably learned it before too. Okay, you have A, you have B, you want to add them together. Okay, of course I draw them from here. A, B. The first method, if you want to find the A plus B, which equals C, usually you show them like this. If you want to draw it, one way is called parallelogram way of adding. So you draw a parallel of A from here, parallel of B from here, and this would be the addition of A plus B, which is actually C. This would be C. Yeah, A, B, and this would be C. Yeah. Okay. This is parallelogram. I'm sure it's very easy for you. Now let's there is another way of adding A and B together, and that way is triangle way. Okay, you can draw A from here. This is your A, exactly equivalent of A, and the B you draw from the end of the A. This would be your B, and then this would be the addition. This is C, which is exactly the same as this C, which is A plus B. So it's exactly, this one is exactly this one. They are exactly equivalent. So the result is the same, but this is called triangle way. This is called parallelogram way. You can please make sure you do this, you know, draw several other kind of things, I mean A and B's, or let's call them M and N, and this let's call K, the addition. Yeah, so try to do things for yourself. Let's say this is N, this is M, and this would be of course K. So draw some different types for yourself and practice these methods, both of them. And something very simple, it is actually, let's find A minus B. Of course, this would be A. And instead of drawing B from here, you draw the minus B. This is actually minus B, sorry, this is minus B. Yeah, so A minus B equals A plus minus B. And of course, you know this is minus B, because if this is B, the minus, like if this is B, definitely this is minus B, right? With the same magnitude, just different opposite direction. So of course then you add them together, and this would be, let's call it D, which is D equals of course A minus B. So of course, if you want to draw it the other way, you say A, and the minus B you draw from here, and of course this would be the D. These are very easy for you, but please practice more. Don't think because it's easy, don't underestimate it. Practice more and play with it. Draw your own, design your own problems, draw them, solve them. And there is one last thing in this lesson I want to tell you, is that if you multiply a number in a vector, so for example, this is A, and you want to find 3 A's, 3A. The 3a would be, of course, just 3 times a, showing the same direction, just 3 times bigger, and this is 3a. This is a vector called 3a. So the result is, of course, a vector. So when you multiply a scalar, a number, in a vector, the result would be a vector, and it's gonna look like this. It makes sense, right? So you just design some other problems for yourself and try to solve them. Okay. Actually, let me tell you one more thing, and that is the looking at the vector in a coordinate